Okay, today we're going to go ahead and start on our first tab of our Unit 13 foldable. The Unit 13 foldable is on families of functions, and we're going to talk about four of them. Two of them should be real familiar, and the other two won't be too hard because we've kind of already talked a little bit about them. But we're going to start on the first tab today, which is on linear functions. In other words, equations of lines. Okay, here's our first slide if you want to write this down, and a lot of this should be review from last year, but I'm going to kind of go through and just talk about it. The equation of a line, they call it slope-intercept form, is y equals mx plus b. M is your slope, okay, which I wrote right here. B is your y-intercept, so if you know those two numbers, you can go ahead and write the equation of a line. Couple reminders, slope is rise over run, so when you have 2 points, you figure out how much one is going from one to the other, up or down, and that's the top number of your slope. The bottom number of your slope as a fraction is how much you're going left or right from one point to another. And we'll talk about that in our notes. So that's right here, if you don't remember. Okay, but slope is rise over run. Okay, and there's a little equation that tells you how to find that if you need it. Okay, your y-intercept. Talked about it before. It's when x is 0. If I draw a little picture here. Okay, let's pretend that's an xy axis. And this is a line. Your y-intercept is where it crosses the y-axis, which would be here. Notice how that x-coordinate is 0. Okay, so whatever that y-coordinate that goes with it, okay, is your y-intercept. But that x-coordinate is always going to be 0 where it crosses the y-axis. And then when you're talking about zeros right here, that's when y is always 0. So think about it. Here's your zeros. We worked on them with quadratic functions. Okay? Y will always be 0 at that coordinate. So you can easily find the zeros for that too. Okay, with the y value of 0. But in general, zeros happen where the line crosses the x-axis. I wrote down here a little bit. Let me scroll down some. Oh, more than I wanted. Okay, if I scroll down a little bit, domain, okay, when we're talking about domain is the x values that show up in a function. Since lines go on forever left and right, then all the x values, you're going to use all of them, so your domain is x equals all reals. Okay, your range are the y values that show up in a function. Most lines, okay, lines go up and down forever, so y is going to equal all reals for that. So just make sure you know that. Let's go ahead and scroll down then. We're going to go ahead and do a practice graph. Okay, which I already graphed it for you. Okay, so let me erase this real quick just to start from the beginning on it. So right here, graph the line y equals negative 2/3 x plus 5. You write that out. Y equals negative 2/3 x plus 5. A little bit easier to see like that. The last number is your y-intercept, so it's 5. And the number in front of x is your slope. So that's your slope. So if you remember how to graph, you put a number on your y-intercept, or put a dot, sorry. So I have a y-intercept of 5. From there, I'm going to use my slope to find the other points on the graph. So the top number of my slope, negative 2, that tells me to go down 2. The bottom number, 3, tells me to go to the right 3. So again, the top number tells you to go up and down. The bottom number tells you to go left or right. So from this point, my slope says go down 2. So 1, 2, and to the right, 1, 2, 3. Okay, and that should be the drawing of my line. Okay, for our second slide, go ahead and copy this down. What they're going to do is they're going to give us a table. And they are going to ask for an equation of a line and then some other information. So I'm going to show you how to answer that. So right now, we know an equation of a line. I'm just going to write it is y equals mx plus b. Okay. So if you remember on the last slide, I said that the y-intercept always happens when x is 0. So if you look at this table, I see where x is 0. It's when y is 2. So your y-intercept is actually 2. Okay, so you don't have to do any work there. And from the slide before, if you remember, slope ends up being rise over run. Okay, rise over run. Well, if you look at this table, your y values are on the bottom. So all of these are your rise. So if you go from one to the next, Okay, if you jump from one to the next, you are going up 3. So your rise is 3 because you're going up 3 each time. The x values determine your run, so if you look at those, what you're going up by, each time you're going up by 1. Okay, so you're going up by 1. So your rise is 3, your run is 1, so your slope should be 3 over 1, which is the same as 3. Okay, so I can write my equation of a line then as y equals m, which is 3x plus b. And you found your y-intercept was 2. Your domain, okay, the x values go on forever in this, left and right, so your domain is all reals. Okay, x equals all reals. Your y values go on forever, left and right, or up and down, sorry, up and down. So your y values are all reals. Your zeros, okay, your zeros happen when y is 0. If you look at your table, there's nowhere where y is 0. That's fine. I know my y value is really right here. If I draw an arrow, my y value is really represented there. So what I can do is I can just put a 0 where y is and set my equation equal to that. So I just stuck a 0 where y is, and I'll just physically solve. So I'll move 2 to the other side and make it -2, and then divide both sides by 3. Okay, so it should be -2/3. Okay, that's where I have a 0. That's where it crosses the x-axis. Then the last part down here, it says rate of change. That's the same as slope. So it wants to know your slope from F1 to F2. Okay, so F1 to F2, if you look at it, F1 to F2 is right here. So my rise there is from 5 to 8, that's 3. Your run is 1 to 2, that's 1. So it ends up being the same thing, okay, that you got for the slope in the equation. And that's always going to be true with the line. Okay, for our last slide, we're going to be given a table that we're going to have to fill in and then answer some questions. You can use your calculator for this if you want, which I'll show you. Right here, though, here's our equation right here. Okay, if you want to use your calculator, you got to have it as y equals, and you would have done this last year. So I'm going to rearrange it a little bit. So I'm going to move 4x to the other side, so it becomes -4x. And then I want to get rid of that 2 by dividing everything by 2. And so it just says y equals. You always want just y equals, so if you divide everything by 2, okay, that's the equation you get. Okay? I'm going to fill out a table by hand, and then again I'll show you with the graphing calculator how it matches up. Alright, so when I have an x value of 1, it wants to know the y value. So again, if I go over here, if I fill in an x value of 1, I can just simply fill that in, okay, and figure out my y value. So -2 times 1 is -2, plus 4 ends up being +2 for that one. So when you put in a y value of 1, or x value of 1, you get 2 out for y. Okay, I can go ahead and do the same thing and fill in 2 for x. Okay, when you fill in 2 for x, you end up getting 0 out for y. And you'll notice a pattern. When you fill in 3 for x, you get -2. When you fill in 4, you get -4. When you fill in 5, you get -6. Which makes sense because your y values are going down 2 each time, which means your slope is -2. And it was up there. Okay, so you can fill in the table real easily that way. This is an equation of a line, which means it goes on forever left and right. So your domain and range are all reals. Okay, your y-intercept happens when x is 0. So I don't have an x value of 0 in my table, but I could easily fill it in. So I'm going to at least fill in an x value of 0 to find my y-intercept. When you do that, you figure out it is 4. Okay, that's what would have showed up in my table had I done that. And then your 0 happens when y is 0. Well, I do see when y is 0 right here, so my 0 should actually be 2. Okay, that's when y is 0. And again, I'm going to look at my rate of change from 3 to 1. So if you look up here, so rise over run, let's find that, rise over run. Okay, so I'm looking at these 2 points, so your y value from 3 to 1 changes by 4. Okay, it's going from -2 to 2. So it's changing by you went from 2 to -2, so -4. And your x values from 3 to 1 are changing by +2. So it should be -2, which makes sense because that is your slope. And it should be the same slope you got up the top. So let's go ahead and look at graphing this and see if we can see some of this information in the graph. Okay, so on my graphing calculator, I'm going to go into y equals. Remember, I changed this equation to -2x plus 4. So you're going to have it as y equals if you want to type it in. So I will hit graph. Okay, there's my graph. Notice here my y-intercept, where it crosses the y-axis, was here, and we said that was 0, 4. That was your y-intercept. And notice where it crosses the x-axis right here is my 0 that I found. So it crossed when x was 2. So that's how I got those two answers. If I want my table to show up, though, and I want to check my table answers, remember, all you got to do is go to second and graph, because that's where your table is. Let me erase that. And you can see our table shows up. And the table we wanted started with an x value of 1 and went to an x value of 5. So that's the table answers that we should have wrote down, which we did, and we got by just plugging in.